In this video, we'll derive sectional formula. I have my Cartesian system in which there are the 2 points given to us, namely P and Q, with the given coordinates x1, y1 for P, and Q has the abscissa x2 and the ordinate y2. The point P and Q are joined by a straight line, and we have another point R on it, which divides the join of PQ in the ratio of m:n. Then what are the coordinates of R? Let's assume x and y. So our aim is to get this value x, the abscissa for R, and the ordinate, the y for R. So let's get started. We'll drop the perpendicular from P on the given x-axis. Let's call this point as S. Same we do from R. Let's call it T. From Q, let's drop the perpendicular. Let's call it U. Since the point P is x1, y1, the distance, that is OS, is x1. The distance from O to T is x because the abscissa for R is taken as x, and the distance from O to U is x2, the abscissa for Q. This distance PS, drop the perpendicular here. This distance traveled on y-axis is the ordinate y1 for P. In similar manner, this distance RT is y, the ordinate of R, and the distance from Q to U is y2. Let's also join perpendicularly from P to R. Stop the perpendicular here and dropping the perpendicular from R on QU. Let's call this point as A and this as B. Now this distance is x from O to T. O to S is x1. This distance becomes x minus x1. The distance parallel, which is PA to ST, will also become x minus x1. This distance is x2 minus x, so is the distance RB, x2 minus x. Coming to this side, this RA distance, the whole distance is y, and this distance is y. This distance finally becomes the distance y, and subtract y1. This distance becomes y2 minus of the distance this, which is y. y2 minus y becomes this distance. Now looking in the triangle PRA and the triangle QRB, this angle 1 is equals to angle 2. If I extend this line, so we know this is parallel to this, and this angle 1 becomes equals to angle 2. Why? Because they are corresponding angles, where we see the transversal QP and the parallel line RB parallel PA. Also, angle PAR is equals to angle RBQ equals to 90 degrees. Therefore, by AA, we can say triangle PAR, similar to triangle P corresponds to R, A corresponds to B, and R corresponds to Q. So this implies their corresponding sides are in proportion. That means PA over RB is equals to AR over BQ is equals to PR over RQ. Going back to the triangle, we see the distance PA is x minus x1 and RB is x2 minus x, whereas AR is y minus y1 and BQ is y2 minus y, whereas PR was M and RQ was N. Solving this further, we'll take this ratio and use this relation to get the value of x, because that's what we are looking for to evaluate x for r, the abscissa for r. Cross multiplying, this becomes nx minus nx1 equals to mx2 minus mx. Bringing the x terms on one side, because that's what we are evaluating. Taking x common, it becomes plus here, m plus n and mx2. This term comes this side with plus nx1. So I get x, which is the abscissa for r, that is mx2 plus nx1 over m plus n. Similarly, we'll use the relation by and m is to n and get the value for ordinate of r. Again, cross multiplying, this becomes yn minus y1n equals to my2 minus my. Now my interest is to find the y for r, which is the ordinate for r. So bringing the y terms on one side, taking this becomes y, taking common m plus n equals to my2 plus y1n. Then further we write my2 plus ny1 over m plus n. So the coordinates of r, which is the point that divides the join of any two given points, is given by the abscissa. X will be equals to mx2 plus mx1 over m plus n, and y would become my2 plus ny1 over m plus n, which is the section formula in the coordinate geometry. Thank you. That's all.